All right, Algebra 2, Module 2, Lesson 13. We're talking about sinusoidal functions when it has to do with the tides, sound waves, and stock market. So if you think about sinusoidal functions, what are they always going to have to do? Think about our sinusoidal function. What are they going to do? They're going to repeat, right? They can keep going over and over and over. Time. Think about time. It's going to keep going over and over and over. So if we have some type of repeating patterns on there, we might be able to set it up in a sinusoidal function. Okay? Like the tides. You have high tide, low tide, high tide, low tide, high tide, low tide. That's going to be repeating. Sound waves. I don't know much about that, but I know sound waves bounce back and forth, right? Different frequencies, but they stay within that range. Then you have the stock market. Now the stock market, hopefully, is increasing, but if you look at it, it's going to be going up and down, up and down, up and down, up and down, but hopefully in an increasing manner. Okay? So, this says the data for the new canal station located on the shore of Lake something in, that would be Louisiana, LA, and Lake Charles, Louisiana, are shown below. So we're looking at these canals, looking at the high tide and the low tide, the tide charts, okay? So number 1 says, what sinusoidal function of the form f of x is equal to the amplitude, sine, all that, that's just our formula, sinusoidal formula there, be appropriate to model the given data for each location. Okay. Now, if we look at this, would it be a sinusoidal function? How can you look at this table and tell if it's a sinusoidal function? Each location, yeah. What do you mean the dates repeat? Oh, because you have two different times of day. Okay. So look at how repeating it is. We got 7 a.m., 7 p.m., 7 a.m., 7 p.m., high, low, and then you actually have the measurements, right? So that would be easy to see that would be a sinusoidal function, right? Let's look at Lake Charles. We've got the alternating low, high, low, high, low, high. So it varies a lot more often, right? You're going just in 7.5 hours, you're going from low tide to high tide, right? So you technically probably could use it, but there's going to be a lot more factors in with that. Okay, and that's what we're going to see too. It's not going to be simply just cut and dry with this formula here. Okay, there's a lot of different factors that we're going to have to take into consideration. Okay, so yeah, probably we would use it for the new canal station, but it would be more difficult for the other one. But more difficult for sure. You're just going to do whatever it says. Sometimes it'll say graph it on the same one. Sometimes it'll say separate. Yeah. Okay. Now, it wants us to write the sinusoidal function to model the data for the new canal station. Okay, so we're going to take it and we're just going to figure out the A, figure out the omega, figure out the H and the K's, and plug it in. All right? So how are you going to find, let's start with A. How are you going to find, we don't care about this one. Okay, let's find A for New Canal. How are you going to find the amplitude? What would you do to find, what is amplitude? What is amplitude? What did you say? Amplitude is not where it starts. Good. Somebody took notes. Look at her with her piece of paper and pencil. How old are you? Gosh, using that ancient form of writing. So what is F? What are those numbers? 0.53 minus what? Josh, are you looking at the answer key? Yeah, you are. Because there's no way you would have said 115. I don't know where they come up with that 115 at on the answer key. Listen, I know I'm dumb looking, but I'm not as dumb as I am looking, okay? Now, if we do that, we should get, what? 0.53 minus 0.11 divided by 2, 21. So the A is equal to 0.21. Okay. Now, let's do, what we're going to do, the period now. So how do you find the period? Are we going to have a pi in this one? No. We're not dealing with the radius or the unit circle, right? What is the period? I just said we're not going to have pi's. What's the formula for finding the period here? What is the period? It's what? Even more basic than that. It's how often what? It repeats, right? It's how often we're repeating. One rotation, what we've been talking about with the unit circle, one rotation is when it repeats. Another repeat. So how often does this repeat? Don't look, hey, stop. Logically, how often does this repeat? Two, four, two, four. I don't even know where you are getting these numbers. What are you talking about? Tell me where you're getting these numbers. Okay. Okay. So you want to see the time difference between the low point and the low point, and the high point and the high point. So what are those? It's about 24. They say 24 and a half, right? From 7:22 to 7:51 the next day is 21 and a half hours. That's when it's going to repeat. So you're going to have a repeating of high or low tide every 24 and a half hours. Now, does that work for high tide? Yeah. We go from 7:11 to 7:58 the next day. Now, it's not exact. It's a little bit more than 24 and a half hours, but it's not 25 yet. You're just going to look and see when it's going to repeat. Yep. So if it was a graph, you would just see when did it repeat, and you would write down that value. Okay. So what did we say? 24.5 hours is when it repeats. Think of this as when does it repeat. Okay. What else do we need to figure out here? H. What is H going to tell us? Okay. Can you speak to me in normal terms? Yeah, we're going to have a horizontal shift, right? Okay, so how do we figure out this horizontal shift? Where's our starting point at? So, yep. More specifically, 7:22, right? Okay. So the easiest thing, that's our starting point. We can't start at 0. We're not starting at midnight, right? We don't have that data for midnight. Well, that's the first point that we have the graph, right? I mean, we can't assume what it's going to be at midnight. So what we would do is think about our horizontal shift. Where's our starting point going to be? Well, it's going to be shifted over 7:22, whatever that is. But we're not doing time, we're doing hours. So what is 7:22 in hours? It's not 7.2. So just do 22 divided by 60, and that's 0.36. So 7.4. Everybody round it? Okay. So 7.4. And remember, H, think of horizontal shift. Now, remember, that is a translation to the right, correct? Because it's positive. But you're going to put that into your formula with a built-in zero. Built-in zero. With a built-in negative sign, okay? Leave that negative sign there. Okay? So, what else do we have? K? Now, K is our what? Okay? What do we call that? The midline. Where is our midline going to be, or how do we find it? Yeah, so take what you did right here, but add it together. 0.53 plus 0.11 divided by 2. So what is that? 0.53 plus 0.11 divided by 2. Your midline should be shifted up to 0.32. Okay? Now, can we slide over here enough? Yeah. Slide over just a little bit, and we'll write this in our formula. Okay? So we have f of x. F of x is equal to what? A, and that is what? 0.21. I don't have enough room here. Let me erase this. I'm going to erase this. And we'll write it right here under it. F of x is equal to 0.21. We're using the sine function, right? sine. Oh, let's see here. We have period here. So how are we going to write the period in here? Is that all we got to do for the period? What's that telling you? What do we do for our period? We found out how much it every time it rotates. So now what are we going to do? What do we put it over? Or under? We put it under, not pi, 2 pi. We got to put 2 pi. So here is 2 pi over 24 and a half. Okay. When we were figuring it out, when we were looking at it, we didn't have 2, we're not measuring it in 2 pi. We were measuring it in hours. Okay, or we didn't have pi's. But to put it in our function, so it's going to be repeating like that, like on a unit circle, we would have to use the pi or the radian. Okay. But don't think, oh, I need to see how many pi's is it rotating, and that's going to be our answer. Because we are not doing it on a unit circle, we're doing it in hours. That's what I meant by that. Now we can do x. And remember, the negative or the minus is built in. So our h is 7.4. And then our k was 0.32. Right, you're looking at a table, and now you're giving me the sign. Instead of looking at the graph and giving me the function, now you're going to look at some data, give me the function, and then guess what you're probably going to do next? Graph it. Yeah. So we kind of went from the graph to the function, from the function to the graph. Now we're going from data to function to graph.